Hello, today I'll present the Cloud Native Best Buy application that we deployed on Azure Kubernetes Service. Our goal was to modernize a traditional retail workflow into a scalable, resilient microservices architecture. In this presentation, I will walk through the architecture decision, show the application running on AKS, and demonstrate our CI/CD pipeline. Our architecture follows cloud-native principle. We decomposed the system into independent microservices: storefront for customers, store admin for staff, product service for catalog data, order service for handling order submissions, make line service for order processing, and RabbitMQ for messaging between services. We also have MongoDB for persistent order storage. The justification for this choice is simply we need this scalability, fault isolation, and the ability to upgrade service independently. Kubernetes orchestrates all these components, ensuring reliability, self-healing, and efficient resource usage. RabbitMQ allows asynchronous communication so the system remains responsive even under load. MongoDB gives us flexible storage for all the documents. Each component exposes a REST API and everything communicates internally using cluster IP services. This design allows us to scale each microservice independently. For example, during Black Friday, we can scale the product service or storefront without touching RabbitMQ or Makeline. Our message queue removes bottlenecks by decoupling order submission from order processing. This gives us high reliability and predictable performance. Using AKS ensures automated rollout, self-healing pods, and strong observability. Overall, this architecture supports modern DevOps practice and reduces operation risk. Let's take a look at our cluster setup. As you can see, we have all our microservices running inside the Best Buy namespace. We use two load balancer services for external access, one for storefront and one for store admin. All other services stay internal using cluster IP so they communicate securely inside the cluster. Now let me demonstrate the application from the user's perspective. Here is the storefront interface, accessible through its load balancer IP. So I can place an order like this and check out. Order submitted successfully. Now let's look behind the scene. The Makeline service listens to the RabbitMQ when a new order arrives. It processes and is stored inside MongoDB. Okay. We should see message. Yes, there we have the 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 order received. Okay. This, conf- this confirms that the order successfully traveled through the entire metro service chain. On the admin side, staff can view real-time orders. The store admin UI fetches processed order from the the store admin UI fetch processes order from the makeline service. This demonstrates the full workflow. This demonstrates the full workflow. Customer places an order service sends a message, makeline service processes it, MongoDB stores it, and the admin UI displays it. We implement in CI/CD using GitHub Action. Each microservice has its own pipeline that automatically builds, tests, and pushes Docker image. After it triggers a rollout in Kubernetes. Here you can see the workflow of one of the repository. Code is pushed to GitHub. The pipeline builds a Docker image. It pushed the image to Docker Hub. A kubectl apply command update the AKS cluster, and Kubernetes performs a zero downtime rollout. This confirms that the new version is now running on the cluster automatically. To conclude, this project demonstrates a fully operational cloud-native retail application powered by Kubernetes. It is scalable, resilient, and fully automated with CI/CD. This architecture positions us for future growth, reduce operational overhead, and aligns with modern cloud engineering best practice. Thank you for watching.